Hello, in this video I'll be talking about solving two-step equations. Before we get into solving two-step equations, I want us to do a little practice on writing equations based on a word problem or based on a phrase. Um, the key to writing an equation or an expression in algebra is defining a variable before you start. The very first thing is define a variable. And I find that students who are used to solving easier problems, uh, they don't do that and they don't get into the habit of that. And then when problems become more difficult, they don't know where to start and they just sit there staring at the problem because they don't know what to do. Um, so defining a variable is a really important skill to develop, and so that's what we're going to work on here. And then once we define that variable, we're going to write an algebraic expression for each phrase. Here's the first one here, 2 points fewer than 3 times the number of points scored before. That can be a confusing thing for a lot of people to read, but the important thing to see is that there's only one unknown thing here. 2 points, that's known, fewer, that's known, 3 times. The number of points scored before is the only thing that we don't know. So we're going to define that as our variable, our unknown. So P is going to equal the number of points scored before. Now that we have that, now that we have a representation of that algebraically, the rest is just translation. So 2 points fewer than something, so like if you had the number 5, 2 points fewer than that would be 5 minus 2. So 2 points fewer, just starting there, we don't know what it's fewer than yet until I read on, but I know that 2 points fewer is going to look like minus 2. That's 2 fewer than something. So now I can forget about that. Then 3 times something. So 2 points fewer than 3 times something. So I'm going to multiply 3 by something. 3 multiplied by the number of points scored before. Well, P is the number of points scored before. So my algebraic expression is 3P minus 2. 2 fewer than 3 times the number of points scored before. Now let's practice with another one here. 8 pounds less than. Okay, well 8 pounds less than 10 pounds would mean like 10 minus 8. So we know that 8 pounds less than is minus 8. 5 times, oh sorry, I jumped the gun on this. I did what I just told you not to do. Let's define that variable that we don't know. The weight of a chicken. We don't know that. So let's call that W equals weight of a chicken. Alright, now that we got that, sorry to go out of order there. 8 pounds less than, still right there, 5 times the weight of a chicken. Well, if W is the weight of a chicken, 5 times that is 5W. And then 8 pounds less is this. So 8 pounds less than 5 times the weight of a chicken. That's it. So now we're going to go into solving two-step equations. I'm going to talk about a couple common mistakes that students make. Remember, there's 4 choices that we have when we're solving these equations. To use inverse operations, we can subtract something from both sides. We can add something to both sides. We can multiply both sides by something or divide both sides by something. So in this case, we have a two-step equation. We have this x here. It's being multiplied by 2. It's also being added to 2, or 2 is being added to it, if you prefer that. So I'm going to model this equation using some algebra tiles here. So that's going to be our x there, and we have 2 of them. So there's 2x. And then there's also 2 regular numbers, so each of these is worth 1. So we have 2x plus 2. And we're going to say equals, I could just write an equal sign here, equals 4. So 1, 2, 3, and 4. Alright, so 2x plus 2 equals 4. Now, some students don't know whether they should get rid of this 2 first or this 2. Well, when you are adding and subtracting to both sides, it's pretty simple. I can add, if I add one to this side, I add one to this side. If I take away one from this side, I take away one from this side. So it doesn't matter what is on either side, I can always add and subtract. It's very simple. Now with dividing and multiplying, if I multiply this side by 2, it has to be the whole side. I can't just multiply one of these terms by 2. It's got to be all of this stuff. So if I multiply this stuff by 2, I'm going to get 2 more of these, and I'm also going to get 2 more of these. Right? And then if I multiply this right side by 2, I'm going to get 4 more of these, right? So that's what happens when I multiply by 2. I'm going to move these over to this side for a moment. Okay. Same thing with the division. If I divide both sides, I have to divide everything on this side by something. So in this case, it would be 2. So if I divide this side by 2, I'm basically cutting it in half. So I'm left with 1 green and 1 yellow, and over here I'm left with 2 yellows. So this would be a division by 2, and I would have x plus 1 equals 2, because everything would have to be divided by 2. And that works out fairly nicely in this case. Now I can just subtract a yellow from each side, and I end up with x equaling 1. Okay, and you can check it. 2 times 1 plus 2 does equal 4. Now the problem is, let me get rid of this stuff. Okay, the problem is if we have an equation that looks like this. So now I have 2x plus 3 equals 6. So I'm going to bring back some of these. So 2x, I've got 3 of these. Oops. There we go. And it's going to equal 6. So let me see if I can get 6 of these over here. What's that? 1, 2, 3, 4, 5. Okay, so again, if I wanted to subtract 3 from both sides, that would be pretty easy. I just get rid of 3 from here, get rid of 3 from here. Oops. Okay, and then I'm left with 2 x's equaling 3. However, if I was going to multiply, divide both sides by 2, that's a little more challenging because I have 2 of these green, so when I divide by 2, one of those goes away. But now I have 3 squares, so when I divide by 2, I get rid of 1 1/2 of them. So I now have a fraction. I would have 1 1/2 squares, okay, which is difficult to model using algebra tiles, but the idea now is you'd have a fraction here that you'd have to deal with. And that's okay, but when I have fractions, I like to deal with them as little as possible. I'd rather stay with whole numbers as much as I can. And so when I get my fractions, I'd rather have those at the very end rather than dealing with them every step of the way. So when you have the option of doing the subtraction or the division, you should deal with the subtraction first, then the division. And the same thing goes with multiplication. So you're always going to deal with the subtraction or addition first, then deal with the multiplication or division. Because remember, with addition subtraction, no matter what's on this left side, you can add to it, right? And then add to the right side. No matter what's on this side, you can subtract one of these from each. It doesn't matter. But when you're dividing and multiplying, dividing in particular, you have to do it to the whole side, and that ends up giving you fractional things. Also, when you're multiplying to both sides, a lot of students forget to multiply everything, and they just multiply one of the terms. Okay, so let's go back to our problem. Let's actually solve this, right? So if we were using algebra tiles, I'd want to do this subtraction first. Get rid of those. Oops, get rid of those 3. So we'll have to get rid of these 3. So we end up with 2x's equals 3. And then now we do have to do the division by 2. So we're going to divide this by 2. So get rid of that. And then we will end up with 1 1/2 squares, however you would model that. So x equals 1.5. And you can check that. 2 times 1.5 would be 3. And then add 3. So the whole reason I was using the algebra tiles there is just to kind of show you what multiplying a whole side would look like, because a lot of students forget that. To solve this without algebra tiles, it's pretty simple. We subtract 3 from both sides, and that gives us 2x equals 3, and then divide both sides by 2, and then we end up with x equals 3 over 2. And that's it. If you were to do the division first, like I showed you before with the algebra tiles, you would just get a fraction earlier. So let me show you. Let's move this stuff more out of the way there. Oops, that didn't work out very well. So if we started and did the division first, it's not that it doesn't work, it still does, but you have to do it to everything. And so here you end up with x plus 3 over 2 equals 6 over 2. And then when you subtract, we're dealing with a fraction, which it works. It's just a little bit more painful for some people. Okay, let's move on. So from now on, when I do my examples, I'll most likely be doing the subtraction addition first. So here I'm going to add 28 to both sides. So I end up with negative 8y equaling negative 5, it looks like. Negative 33 plus 28 is negative 5. Now to get rid of this multiplication by negative 8, I just divide by negative 8. That cancels out the negative 8's, leaving me with y equals, and the negative divided by negative is going to be positive, so y equals 5/8. Let's try 2 more. So in this case, we have an x being divided by 5. It's also being 35 is being added to it. Again, I'm going to want to deal with that addition first. And we're going to use subtraction. So we're going to end up with x over 5 equals, looks like 40. Okay, now the inverse of dividing by 5 would be multiplying by 5. And so we'll end up with x equaling 4 times 5 is 20, so this will be 200. Let me move this out of the way here. So now we want to double check our answer because this had some bigger numbers in it. So 200 divided by 5 would be 40, plus 35 is 75. Now let's try this one. Alright, new problem. So here again we have some multiplication, that is a 0.79. We have some addition, so we're going to want to deal with this addition first. Subtracting 1.25. Remember, when you're dealing with decimals and subtraction, you have to line up the decimals. We're going to borrow 15 minus, oh, I don't know why I borrowed. You don't have to borrow. Skip the borrow. Back up. Okay, there we go. 5 minus 2 is 3, and then 7 minus 1 is 6. So we're going to end up with 0.79m equals 6.32. Oh, this looks like it could be somewhat painful, so we're going to have to divide by 0.79. Divide by 0.79. And so that looks like 632 divided by 79. So it does not go in to 6 or 63. It goes into 632, I don't know, maybe 7 times. That's a guess. 49.55. Alright, if I were to add 80-ish to that, I would end up with 630. Ooh, that might be exact. Okay, let's check it out. 79 times 8 is 72, 56, 63. Yeah, it's exactly 8. So we're done. So m equals 8.